Recap, children. We are back to work today doing solving trig equations. This is the lesson for Tuesday, the 24th of March during our shutdown, however you want to call it. Pretty much driving me crazy. Probably driving you guys crazy too. Wish we could be back at school. Hopefully soon. All right, so we're going to solve equations, and it looks like they want us to work in degrees, even though the degree symbol is not there. And we're going to take any answers that exist between 0 and 360 degrees. So one thing you can do is notice that there is a double angle in this, and you can say, I choose not to work with that double angle. Go to the formula sheet and grab something that's equivalent. I'm going to use 1 minus 2 sine squared x. And this right side still says 1 minus sine x. And you're going to get everything over to one side. So I'm taking all of these terms from this side and bringing them over here. Alright, so that means you'll have this thing equal to 0. And they cancel. So I'm going to write the 2 sine squared first. Seems more natural. Minus sine x. And then you're just going to go ahead and factor out the common term, which is sine x, leaving you with a 2 sine x minus 1, and we are equal 0. And same thing as a regular quadratic. Set each term equal to 0. And over here you end up, and I'm going to do that in my head, as I know you guys can do as well, that the sine x is just equal to a half. Okay, so you're going to think, and remember, where is the sine x equal to 0 on your unit circle? And that happens at 0 degrees and 180 degrees. And where is the sine x equal to 1/2 on the unit circle? That's going to be at 30 degrees. And there is another positive sine value of a half way over at 150 degrees. So your list of answers are 0, 30, 150, and 180. And a new pencil is needed. Here we go. All right, so that's our do now. Pretty straightforward. And let's jump right into our exercise 1. Okay, so all of these have some kind of an example. Like if an equation contains a double angle only, then it might be better to just solve it for the double angle directly. In which case, if you try to substitute 2 sine x cosine x, you'll end up with 2 functions and end up hitting a brick wall. So in this case, I'm going to let the double angle exist. I'm going to divide by this 2. So sine of twice some angle is equal to a half. Now, for a minute, just think about this. The sine of something is a half. Think about the 2x. What angle would someone have to take the sine of in order to get a half? Well, that means that what's in this little cloudy bubble would have to be 30 degrees. So what you're saying is that this double angle, this 2x, has no choice but to be exactly equal to 30. Now we got to be careful also, because Sine is positive in quadrants 1 and quadrant 2. So 30 degrees is not the only thing that this bubble could be. This bubble could also be 150 degrees, as we've seen from the do now. So that means not only could the double angle be 30, it could be 150 degrees. And then, of course, you got to solve both of these. So you're telling me that x could be 15 degrees, or x could be 75 degrees. All right, so there's still more to this. Because we're dealing with a double angle, and as when I divide by 2, I make it half the size, you have to be very careful and get all answers that exist between 0 and 360 degrees. So what we're going to do is take this 30 degrees that you found. We're going to add 360 degrees. We're going to cycle all the way around the circle to 390 degrees. And we're going to do the same thing here with the 150. I'm going to add 360 degrees and cycle all the way around to 510 degrees. Well, why are we doing that? Well, again, remember, it's a double angle, so that means that the actual x value is half the size, and you might inadvertently, that's supposed to be a 9. I don't have an eraser on this pencil. It's a useless pencil. You might inadvertently miss some answers. So if you solve these and divide by 2 and it's in between the 0 to 360 range, then we have to count it as an actual answer. So x equals 195 degrees. And over here, you've got x equals 255 degrees, and sure, they do fall inside of the restriction 0 to 360, so we count it. All right, so you have 4 answers. You've got 15, you got 75, you got 195, and you've got 255 degrees. Okay, so that's one option for today's homework, is to just deal with the double angle, but be careful of this section. That's pretty tough. All right, and then part 2, exercise 2, down on the bottom says, perhaps you apply an addition formula. And that's from earlier. You can look at this, or subtraction formula, 0 to 360, I keep forgetting my degrees. All right. So we're going to treat this as u, and we're going to treat that as v. So we'll use the formula and say the sine of 60 cosine of x minus cosine of 60 times the sine of x. And that's equal to 2 sine x. All right. So actually, no, the sine of 60 is radical 3 over 2. Cosine x minus, and the cosine of 60 is a half sine x equals 2 sine x. All right, I'm going to start bringing this to the other side. These are like terms. That's no longer there. And if you have 2 added to a half sine x, that's 2.5 sine x, or otherwise put as 5 halves sine x. Some of you would rather put 2.5, that's fine. So now we still have this left side radical 3 over 2 cosine x. I'm going to divide both sides by the 5 halves. so it's no longer here. And that would require a state change flip because that's a complex fraction, so you're actually doing 2 over 5. So the 2's cancel, so we're really dealing with a radical 3 over 5 cosine x equals sine x. All right. So at this point, I'm going to divide by cosine x here, divide by cosine x here, essentially creating a tan x. So right now I'm looking at the tan of some angle is radical 3 over 5. All right, now that's not one of the nice angles on our unit circle, so that means I'm actually going to have to get my calculator out, get a reference angle, and figure out the tan inverse of radical 3 over 5. Okay? Boop, boop, boop. You type that into the calculator, and I believe your reference angle is like 19.1 degrees. Now tan is positive in quadrant 1 and quadrant 3 because everything is negative, negative. So in quadrant 1, do nothing, 19.1 degrees. In quadrant 3, you're going to have to do 180 plus 19.1. So our final solutions are 19.1 degrees and 199.1 degrees. All right, that question was pretty tough again. But the start was using a addition or subtraction formula. All right, so let's get to the back. Exercise 3, they give you some advice here. You can set it equal 0, you can factor. You got GCF, DOPS, or unfoil. All three of these work. So in this case, I'm going to subtract sine of 2x over to here. So I have cosine x minus sine of 2x equals 0. Okay, so this part, right, that's a double angle, really annoying. You put a sub in for it, which is 2 sine x cosine x. And you bring down the cosine x, and now you have a GCF. So I'm going to take the GCF cosine x out, leaving you with 1 minus 2 sine x. And you do split this, and you say cosine x equals 0, or 1 minus 2 sine x equals 0. Okay, same thing. The cosine is 0 at 90 degrees and 270 degrees. Okay, so that side is set. This side, if you subtract the 1 and divide by -2, you end up with sine x equaling a positive 1/2. And again, that's going to happen at 30 degrees and 150 degrees. Okay, I don't care if you leave them written like this or you actually write them out in roster notation as I've been doing. I'm probably just bored today. So that's all there is to that. And then exercise 4. Last one. So in the event that you have to square root both sides, just watch out and make sure that you include a plus or minus on the numerical side, or else you're going to miss some of your answers. So if you begin solving and you say plus 3, legit move. So 4 cosine squared x is equal to 3, and then you'd say I'll divide by 4, another legit move. So cosine squared x is equal to 3/4. Okay, so here's the moment of truth when you square root both sides. So you get cosine x, and on the numerical side, that's right here, you sneak that plus or minus sign in. Square root of 3, nobody knows. Square root of 4, I know is 2. So if you don't put that plus or minus, you will not search for all available answers. So if you say that cosine x is equal to the positive radical 3 over 2, you'll get some answers. If you say that the cosine of x equals negative radical 3 over 2, you'll get other answers. And so, equaling radical 3 over 2, I happen to have my circle in my head. So cosine is positive in quadrant 1 and quadrant 4. In quadrant 4, I do 360 minus the 30, 330 degrees. And cosine is negative radical 3 over 2. That just means we are in quadrants 2 and quadrant 3. So our reference angle is still 30. So you end up doing 180 minus the 30 for 150 degrees. 180 plus the 180 plus 30, and that is the 210 degrees. So you have all four answers. 30 degrees, 150 degrees, 210 degrees, and 330 degrees. All right, so that's the last lesson for this unit. You guys are going to be doing a review after that. Now what I did do here is write down some helping hints as you're working through these questions. So on number 21, use a double angle, set it equals 0, GCF. Number 22, do DOPS, see exercise 1 from our classwork. Number 23, multiply by 2 on both sides, use a double angle, see exercise 1. Number 24, I actually say you're allowed to skip, so go ahead and skip it. Number 24 is a skip. Number 25, double angle cross multiply. Set equal to 0. GCF. Okay, you don't have to do it that way, but it helps. Number 26, move the tan x to the right hand side and treat the same as number 25. Number 27, double angle substitution. A substitution from Pythagorean identity. And this should make the entire equation sine x, so you set it equal to 0 and you can solve it. Number 28, double angle simplify. You can get it to be equal to tangent if you can. You can. 29, double angle, all sine x, set equals 0, unfoil, solve. And number 30, use a double angle, set it equals 0, GCF, and solve. And it says that one factor, you should manipulate to tangent, and you're going to have to use your TI-84, so one of the answers is ugly. All right, so I'm going to get this posted, and that's that.